Dixon Quick Couplings is a division of Dixon Valves, which specializes in the design and manufacture of hydraulic and pneumatic quick disconnect couplings for industrial applications. For the last 75 years, they have been leaders in innovation and manufacturing. Today, they provide high-quality products from their facility in Dallas, North Carolina.
Hydraulic quick disconnect couplers are used to allow lines to be inspected, replaced, or changed more easily and more efficiently by a single person. Oftentimes, a piece of machinery or farm equipment will require multiple couplers of different sizes to be connected for proper operation. As you can see, it is an inconvenient and timely operation for the user, especially if there are multiple couplers of various sizes. This is where our modular coupling adapter project fits well into the business as an asset for quick maintenance needs.
Our objective is to develop a modular plate hydraulic coupler quick connect system. The system is designed to allow for all couplers of various sizes to simultaneously lock and actuate through the use of a single mechanism. The system is modular to allow for a user to configure the number of couplers needed in a specific arrangement.
Our team analyzed the force required to connect multiple couplings while under a maximum pressure of 5,000 psi. The safety factor of the design is a factor of 4 to 1 according to Dixon's design criteria. The design must be easy to use while allowing the user to safely connect under the load. From our calculations, the force required to mate the couplers would be too heavy for a single operator. A detachable gearbox was designed to solve this problem. Many gear ratios were analyzed to minimize the input force required, and it was decided that an input of 30 pounds of force is reasonable. The gearbox was designed to allow for a single 3/8 drive ratchet to input the torque and transfer the torque through two male 3/8 drives. The design includes side latches and notched pins to align and secure the modules side to side. Once the design was finalized, we tested our design with a 3D printed prototype. The prototype helped us to fine-tune the design for fabrication.
To manufacture our design, various processes were used. The modules were rough cut and faced using a horizontal bandsaw and a CNC mill. The T-slot feature on the top and bottom of the modules were profiled using a wire EDM. This enabled the design to maintain tight tolerances while creating complex geometry. The faces of the modules were then CNC machined to create the various locking features. The pins, plates, and latches were created using manual mills and lathes. The gearbox housings were CNC milled and bearings were pressed in using an arbor press. The gear keys and shafts involved milling, EDM and CNC machining, and welding.
Our planned test procedure was unable to be completed due to COVID-19. The team was, however, able to verify the design at various stages of manufacturing to check for fit and functionality. Some video was captured of the testing, including the side latch performance as you can see demonstrated here. The side latches lock the modules side by side to aid in alignment and ease of modular adaptability. The fit of the T-slot was also evaluated for stacking the modules vertically. In addition, we tested the rack and pinion to ensure proper engagement. Once the assembly was ready, we tested the input torque on the pinion gear to ensure the rack and pinion interface worked properly in connecting the modules and couplers.
Our team was successful in designing a modular quick connect system. We started with an idea, transformed it into CAD, performed many calculations, rapid prototyped the design, manufactured the components, assembled most of the parts, and tested some of the design. Due to COVID-19, we were unable to finalize assembly and testing at Dixon headquarters involving the impulse and high pressure testing. The Dixon Mod team came to an agreement with Dixon members on current progress and considered the project a success.